Hello, this is a video on exponents again. Assuming you have watched the first one on the introduction of exponents and exponent laws, we are now going to do a few examples. There will be 3 levels of examples. The first one is what we are doing now. Then it will get a little bit difficult and the sums will change a little bit. But please watch all of the videos. Pause whenever you feel the need to. If the explanation was a bit too fast, replay it, pause it, attempt the question by yourself, and see if you've got it right at the end. Okay, so let's start. So let's choose a nice color, green. Okay, let's make it a little bit thinner too. Okay, so over here we've got a cubed divided by 2 squared. Okay, so the thing about exponents, there's many ways of attempting the same question, so it all depends on you. So what I'm going to do is I'm going to, instead of having the actual division side, I'm going to write it as a quotient. Okay, then what we're going to do is the exponent law where we distribute. Okay, and when we're raising to a power, if you remember from the last video, we multiply. So this is 3 times 2. And when we don't have an exponent, we know it's 1. And that's times 2. So I'm going to continue over here. This is a to the power of 6 over 2 squared, which you can write as a to the power of 6 over 4. Okay. So that wasn't so bad. Let's give another question a chance. Okay, so here we have this one here. A little bit of advice is always break into prime bases. I'm going to write PB for prime bases, right? So what we do is we write it as its prime factors. So 8, for example, is 2 times 2 times 2, in other words, 2 cubed. That's how we get 8 by using the prime numbers. How do we do this? Well, we take 8 and we say, what is the smallest prime number that will go into 8? And we say 2. We divide through and then we have 4 and we say, what is the smallest prime number that will go into 4? And again, it's 2. Divide through by 2 and then we get 2. And we say, what's the smallest prime number that goes into 2? And once again, it is 2. When we have 1, that is when we stop. So in other words, 8 can be written as 2 times 2 times 2, which is 2 cubed. Alternatively, you could use a calculator. There should be a factorizing button, but you should really know how to do this in your head. Anyway, so then we're going to break 27 up into its prime bases, which is 3 cubed, so power of minus 2 over 3. Okay, then we're going to use that distributive law once again. So this is 2, 3 times minus 2 over 3 to the power of 3 times minus 2 over 3. So as you can see, I'm doing it step by step so I don't get confused along the way. It's when you skip out steps without being properly comfortable with how they work is when you start to make mistakes. So while you're still getting into the hang of it, write out each step. Even though it might take a bit longer, it's worth it to get your answer right. Okay, so here we've got multiplication of fractions over here, something that I think a lot of you are scared of, but 3 times 2/3, negative 2/3 is just minus 2, as the 3 in the numerator cancels out with that one. Over, again, the 3's cancel out, leaving you with 3 to the power of minus 2. So we normally write the powers of positive exponents. So what we're going to do is we're going to swap it over to make it positive. Okay, so I'll write it here. So the 3 will go to the numerator and become a positive, and the 2 will go to the denominator to become a positive. So this is 9 over 4. Okay, another one. Okay, so once again, prime bases first, and then we proceed with the laws. So 3 is a prime number, so we can write it as is. 16 we can write as 2 to the power of 4. It's the power of a quarter. Okay. So this 3 minus 2, first let's get rid of these brackets. when raising to a power, we multiply the exponents. So that's 4 times a quarter. So we have 3 to the power of minus 2 times 4 times a quarter is just 1. So that will just become 1. So this 3 we want to make positive, so we're going to move it to the denominator, but the 2 is happy or positive in the numerator. So your final answer is 2 over 9. Okay. Next one. Okay, so let's look at this one. From this here, we have 5 to the power of 0, and we know anything to the power of 0 is 1. So I'm just going to actually replace that with the 1. This 2 has a negative exponent, so we're going to move it to the denominator. So that will become 2 to the power of positive 3. And this 3 has a negative exponent in the denominator, so we're going to move it over to the numerator, and the power will be positive. So this is just 9 over 2 cubed is 8. Okay, here's another one. Once again, we have our prime bases. Okay, 32 as a prime base is 2 to the power of 5. Okay, and that's the power of 2 over 5. So can you see I've just replaced the 32 with 2 to the power of 5 plus 2 to the power of minus 2 over minus 1. Okay, let's get rid of these brackets over here. So we're going to multiply the 5 and so this is 2, 5 and the 2 fifths plus 2 to the power of minus 2 minus 1. 5 times 2 fifths, that 5 cancels out in the denominator, leaving you with just 2 to the power of 2 plus 2 to the power of minus 2 minus 1. Ha! Now this is a place where most people make a mistake, okay? What they do is they distribute this minus 1 to each term. Is that correct? Well, I'm sure you've guessed the answer by my tone. No. So the rule here is, I'm going to write it here. You cannot and will not distribute over addition or subtraction. Okay, so we cannot distribute over that. We have no other option but to first simplify what's in the bracket. Okay, so this here is 4, and this we can write as 1 over 4. Because we're going to take, that will go 1 over 2 to the power of 2, which is 4. Now this is a fraction, so we're adding fractions, so we want to make an improper fraction. This here is going to be over 4, 16 plus 1, which is 17 over 4 to the power of minus 1. Now we can distribute this minus to the 17 over there and to the 4 over there, because now what we have is multiplication or addition being the operation here, which it's fine to distribute. So we have 17 to the power of minus 1 over 4 to the power of minus 1, and they both need to be swapped around. Okay. Another one. Okay, so here we have a mixed fraction. So first we're going to convert it to an improper. So over 4 times 2 plus 1, so that's 9 to the power of minus a quarter times. Now I'm going to do something that you don't have to do, but it's optional. I'm going to, instead of writing the square root, write it in exponent form, which is a half. You'll remember this from the last video because I did go over this. Okay, so then the next step is to break into prime bases. 9 is 3 squared and 4 is 2 squared to the power of minus a quarter times, okay, and that's 3 over 2 cubed to the power of a half. Now we're going to use the distributive law for each one of them. This is 2 times minus a quarter over 2 times minus a quarter, okay, times 1 times a half over 3 times a half. Okay, so like I said, I'm breaking up each step just so that you guys can see wherever we're making any sort of, whenever we're using a rule. Okay, so 2 times a quarter is a half. And again, 2 times a quarter is still going to be a half, minus a half, because it's negative a quarter. So this here is 2 to the power of minus a half, times, okay, and this is 3 to the power of a half, over 2 to the power of 3 halves. Okay, 3 times a half. Okay, so now we're going to use the rule when we're multiplying, we're adding the exponents. Okay, so I'm going to multiply numerator with numerator and denominator with denominator. So in the numerator, we have 3 minus a half, and we're going to add the other one, which is a half. And in the denominator, we have 2 minus a half, and we're going to add the other one because we're multiplying the denominator with the denominator. So we're adding the exponents. So a half plus a half is, oh, that's an ugly 3, 0, and minus a half plus 3 halves is just 1. So in other words, this is a half. Okay. We're really looking to getting those A's in math, so practice makes perfect, so that's exactly what we're going to do. So over here we have this sum over here. So first thing, prime bases if there's numbers that don't have prime bases. So once again, 8 is 2 cubed, a to the power of minus 3, b to the power of 12, to the power, all to the power of minus 2 over 3. I'm going to distribute that. So this is 2, 3 times minus 2 over 3, a minus 3 times minus 2 over 3, b 12 times minus 2 over 3. Okay, now let's multiply those fractions. 3 times minus 2 over 3 is minus 2. The 3's cancel out. 3 times minus 3 times 2 over 3 is positive 2. Because now the minuses make a positive and the 3's cancel out. And 12 times the 2 over 3 is minus 8. Okay, so the last thing is we're going to make those negative exponents positive over there by taking them over to the denominator. So the a squared is positive. It's happy in the numerator. You leave it there. It's the 2 and the b that want to be moved to the end. You can just do one more step to write that as 4b 8. Okay. Here's another sum. Okay, there's no need to break up into prime bases in this case because they're prime numbers. 3 and 2 are prime numbers. So we're going to go straight over to distributing. Now here's an interesting one. We have minus 3 to the power of 3. Now, if it was an even power, that minus is going to disappear. But because it's an odd number, it's still going to be minus, and it's, equals to minus 3 cubed. Okay, and then we have x to the power of 4 times 3, so it is 12. I'm skipping out some steps here. Okay, we've got that 2, and anything to the power of 0 is 1. So this whole thing is 1. So let's multiply this. This is minus 3 cubed times 2 times x to the power of 12. So that 3 cubed is 27 times 2 times x to the power of 12. So this is minus 54 x to the power of 12. Okay, so the important part was to pay attention to this negative over here. How we deal with it for a positive, an odd exponent and an even exponent is different. So a negative, let's just write a note, with an odd exponent, so I'm going to write plus odd exponent, is always negative. Okay, and any positive or negative plus an even exponent is positive. Okay, so that's an important point, and just remember this for the future. But let us continue with our examples. Okay, so again, first step, prime bases, and I am going to change the square root over here into its exponent form, which is a half. So there's the square root. So I'll write square root. Okay, and then 4 is 2 squared, x to the power squared, and y to the power of 36. All I've did was rewrite those. Again, prime base, 9 is 3 squared, x to the power of minus 2, and then we have minus a half. So what we're going to go ahead and do is distribute again. Once again, I'm going to skip out the step where I write out each multiplication, but we're going to multiply this with each of the stuff inside the brackets. So 2 to the power of 2 times a half, so that's 2 to the power of 1. 2 times a half is, again, 1. 36 times a half is 18. Okay, 2 times negative a half is negative 1, and minus 2 times negative a half is just 1. Okay, let us go and simplify that. So this x to the power of 1 and that x to the power of 1, they cancel out. Okay. This 3 is negative in the denominator, so we're going to move it to the numerator. And then we still have that 2 there, and we have the y to the power of 18. Oh, that's a terrible 18. 18. So this here is 6y 18. Let us continue. I think this might be the last one. Yep, this is the last question. Okay, so again, I'm converting this root sign to a power. So this is to the half. Okay, and I'm changing the 16 to its prime bases, which is 2 to the power of 4, x to the power of minus 8. Now the cube root. What is this as a power? Well, if you remember from the last video, it's 1 over 3. So that's the cube root. Okay, 64 as its prime bases, that's 2 to the power of 6. And that's x to the power of 6. So now what we're going to do is distribute. 4 times a half is 2. Minus 8 times a half is minus 4. 2 times a third is 2. 6 times a third is 2. And 6 times a third is 2. So now let's add the ones on the same base. It's the 2 plus the 2. And for the x's, we have minus 4 plus 2. So this is 2 to the power of 4, x to the power of minus 2. And we'd want to write that as a positive power. So it's 2 to the power of 4 over x squared. If you want to write that in number terms, that is 16 over x squared. Okay. So that is the end of the examples of this one over here. There's gonna be more examples coming up, so look up for the exponent examples, and they'll be a little bit more different. I think we should all be very proud of ourselves for doing so many questions. You've been extremely productive, and please comment about the type of questions you'd like to see, about the type of work you'd like to see, and subscribe. And thank you.